In this video, we want to find the radius of convergence for the sum of 2 times k factorial times x to the 5k over 3k raised to the kth power. So we're going to be using the ratio test, which means we have to look at the k plus first term over the kth term, and we're looking as k approaches infinity. Notice here we're dividing two fractions, so we're going to multiply by the reciprocal. So we're going to multiply by the reciprocal of the bottom fraction. So that's going to be 3k all raised to the kth power over 2 times k factorial times x to the 5k. And now we're going to switch these two. So because we're multiplying these, we can switch the order in which we multiply. So now, if you look at the first fraction, they're basically of the same form, and so is the second fraction. Okay, so now we can do a bunch of canceling. So first, we have x to the 5k plus 5 over x to the 5k power. The 5k is going to cancel. And then we have k plus 1 factorial over k factorial. K plus 1 factorial is k plus 1 times k factorial. So the k factorial is going to cancel, and you're just going to be left with k plus 1 at the top. The 2 also cancels. So that gives us k plus 1 times x to the 5th times 3k raised to the k power. And then over here, 3k plus 3 raised to the k plus 1 power is just 3k plus 3 times 3k plus 3 to the kth power. So I just broke this out into 2. Because now I can factor out a 3 here, and then that's going to cancel with a k plus 1. Okay. So now this third will come outside, and then I can bring 3k over 3k plus 3 under the power of k, since they both share the kth power. So think of it as like factoring the kth power. And then from here, I'm going to use a little trick where I'm going to be looking at 1 over the reciprocal. Okay. So 1 over the reciprocal is going to equal the original. Okay, so that's the trick here. So 3k over 3k plus 3 raised to the kth power. We're going to take 1 over the reciprocal of that, which is 1 over 3k plus 3 over 3k raised to the kth power. And then I'm just going to put the limit on the bottom. So technically, it'll be at the top, but then you can also bring in the bottom. So it really doesn't matter. Okay, from here, I'm going to split this up into 2 separate fractions. And we basically have 3k over 3k plus 3 over 3k. 3k is going to cancel. We have 1 plus, and then the 3 is going to cancel. 1 over k. That's going to be raised to the kth power. And we know that the limit as k approaches infinity of 1 plus 1 over k raised to the kth power, that is equal to e. So right now we have 1/3 times x to the 5th times 1 over e is less than 1. So this has to be less than 1 in order for the series to converge by the ratio test. So we'll multiply the 1/3 and 1 over e to get 1 over 3e, x to the 5th. And then we'll multiply both sides by 3e to get x to the 5th is less than 3e. And so this is going to be our radius of convergence. Or actually, first we have to take the 5th root, and then that's going to be the radius of convergence. So that is our answer.